What if I told you there are 10 free, open-source tools on GitHub right now that security researchers use to completely analyze, intercept, and audit Android apps? Today, we're not just listing them. I'll show you exactly how to install each one, which operating system to use, and real hacking scenarios for each. Let's go. MobSF Mobile Security Framework. The first tool is MobSF Mobile Security Framework. This is the all-in-one scanner. You drop an APK in, and it tears it apart for you. Static analysis, dynamic analysis, API vulnerability scanning, everything. Security researchers at major companies use this daily. What it does: MobSF performs both static and dynamic analysis on Android APKs. Static analysis decompiles the app and scans for hard-coded secrets, insecure permissions, weak cryptography, exposed components, and misconfigurations, without ever running the app. Dynamic analysis runs the app in an emulator and monitors runtime behavior. Network calls, file writes, API abuse. Best OS? Kali Linux. Best Ubuntu. 2204. Excellent Mac OS. Works Windows Docker. Only installation on Kali Linux. Method: first you can install, then clone the repo, and then run the setup. Real example scenario: you download a banking app, APK, from APK Mirror. You drag it into MobSF's web interface at localhost 8000. Within 2 minutes, MobSF shows you hard-coded API key in strings XML, an exported activity with no permission check, anyone can launch it, and clear-text HTTP traffic to a legacy endpoint. You now have a full vulnerability report without installing the app on any device. Watch what happens when I drag this APK in. See these red flags? Hard-coded secret key. Exported components. Clear text traffic allowed. This took literally 90 seconds. That's MobSF. Now let me show you something more surgical. Frida Dynamic Instrumentation. Toolkit. Number 2 is Frida. This is the surgeon's scalpel. While MobSF is an automated scanner, Frida lets you hook into a live running Android app and change its behavior in real time. We're talking SSL pinning bypass, root detection bypass, and intercepting function calls as they happen. What it does: Frida injects a JavaScript engine into a running process. You write small JS scripts that hook any Java or native function in the app. Classic uses: bypass SSL certificate pinning, so Burp Suite can intercept HTTPS traffic. Bypass root detection, so the app runs on a rooted test device. Dump decryption keys from memory as the app generates them. Best OS: Kali Linux. Best any Linux. Excellent Mac OS. Works Windows Works installation process. I can provide these resources, which you can download and test in your Linux. Real example of SSL pinning bypass. Here is the method of SSL pinning bypass. That green line, SSL pinning bypassed, means this app that was blocking all traffic interception. Now every single HTTPS request it makes goes through Burp Suite. We can see passwords, tokens, everything. This is why app developers need to test their own apps with Frida first. JADX Java Decompiler. JADX is your X-ray vision for APKs. It takes any Android app and decompiles it back to readable Java code with a beautiful GUI. No terminal commands needed. This is the first thing most researchers open when they get an APK. JADX converts compiled Dalvik bytecode .dex files inside APKs back into human-readable Java source code. It handles obfuscated code better than older tools like GUI, resolves resource references, and shows you Android manifest.xml with full permissions, activities, receivers, and services listed. Best OS: Kali Linux. Best any OS with Java works. Great installation. This is an installation process. Real example: open a banking app in JADX GUI. Navigate to strings .xml in the resources tree. Search for API key, secret, password, token. In real-world bug bounty reports, researchers have found hard-coded AWS access keys, Firebase credentials, and payment gateway private keys this way, all visible in plain text after decompilation. I'll just do Ctrl+F and search for password, And there it is. Hard-coded database credential in the source code. The developer forgot this was there. This is one of the most common vulnerabilities in Android apps, and JADX finds it in seconds. Objection. Runtime. Mobile exploration. Objection is built on top of Frida. But instead of writing JavaScript hooks yourself, it gives you a command line toolkit with dozens of pre-built exploits. Think of it as Frida for beginners that experts still use every single day. What it does, Objection wraps Frida's power into easy commands. Bypass SSL pinning with one command, dump all SQLite databases, list files the app can access, bypass root detection, explore shared preferences values, and even patch APKs to be non-rooted Frida compatible without a rooted device. Best OS, Kali Linux. Best Mac OS, good Windows. Painful installation plus real commands. This is the method of installation as you can see the commands. One command. Android SSL pinning disable. Done. No JavaScript, no config files. That's why Objection is the first tool you install after Frida. It also patches APKs without needing a rooted phone, which is huge when you're testing in the field. ADB Toolkit, Android Debug Bridge, ADB. ADB, Android. Debug Bridge is the foundation everything else is built on. If you're doing Android security research and you don't know ADB, you're not doing Android security research. Let me show you what it can really do. ADB is Google's own tool for communicating with Android devices. For security research, it lets you pull APKs directly from a device, access shell, forward network ports, install tools like Frida Server, extract databases and files, take screenshots, record screens, run commands as root, and brute force pins on test devices. Best OS Kali Linux, best any Linux, excellent. Mac OS, good Windows works. Installation plus real power commands. That command right there pulling shared prefs. I've found session tokens, OAuth access tokens, and even plain text passwords in apps with millions of downloads. Developers think this storage is safe. It's not. Drozer. Android Attack Surface Analyzer. Drozer finds vulnerabilities that static analysis completely misses, because it actually attacks the app the same way a malicious app on the same phone would. This is inter-process communication exploitation. Drozer acts like a malicious Android app running on the target device. It probes exported activities, content providers, services, and broadcast receivers. It can launch activities that should require authentication, query content providers for data leakage, send forged intents, and exploit path traversal vulnerabilities in content providers. Best OS Kali Linux, best any Linux. Good Windows avoid installation, inside Drozer. Real attack commands, run app.package attack surface, and Drozer tells you 4 activities exported, 2 content providers, 1 broadcast receiver all accessible without any permission. Every one of those is a potential entry point. That's your attack surface mapped in 5 seconds. APK Tool APK. Reverse engineering. APK Tool is how you disassemble an APK down to its raw smally code and, more importantly, reassemble it. This means you can modify app behavior, remove certificate pinning, disable license checks, and repackage the APK. All for authorized security testing, of course. APK Tool decodes APKs to Smally, Android's assembly language, XML resources, and assets. You can read the Smally, modify it, and rebuild a modified APK. This is used to patch apps for dynamic analysis, for example, removing certificate pinning code at the bytecode level, or adding logging statements to trace execution flow. Best OS Kali Linux. Best any OS with Java. 8+, works great. Installation plus real patching workflow. Here is the method. The whole workflow is decode, modify, rebuild, sign, install. Once you know this, you can patch literally any behavior out of an app. This is the basis of every APK mod tutorial you've ever seen, but here we're using it to remove security restrictions for legitimate testing. Burp Suite is the industry standard for intercepting HTTP/HTTPS traffic. But modern Android apps use SSL pinning to block it. This GitHub script, combined with Apktool, patches the APK to trust your burp certificate automatically. No root required. The Android SSL pinning bypass script from HTTP Toolkit automatically patches an APK using Apktool to disable SSL pinning. It modifies network security config.xml and injects a network config that trusts user-installed certificates. Combined with Burp Suite set as the Android proxy, every API call the app makes becomes readable. Best OS? Kali Linux is best Mac OS. Good Windows burp works. Script needs. WSL, full setup. Workflow. Now I'll tell you the full setup as you can see on your screens. There it is, decrypted HTTPS traffic from an app with SSL pinning. Authorization header with a JWT token. Request body with user credentials. If this API has an IDOR or injection vulnerability, we'll find it right here. This is the most important workflow in mobile pen testing. House Frida GUI. Interface. Writing. Frida scripts in a terminal gets tedious. House is a web-based GUI for Frida that runs on your local machine. You can browse loaded classes, select methods to hook, write scripts in a proper editor, and run everything with a click. Huge productivity booster. What it does, House provides a browser-based interface for Frida. It connects to your Android device via Frida server and lets you browse all loaded Java classes and methods in real time, generate hook templates automatically, edit and run Frida scripts in a syntax-highlighted editor, and save scripts for reuse across assessments. Best OS for this? Kali Linux. Best any Linux. Excellent Mac OS. Good installation. This is how you can install this tool in your OS. Then you can check in your browser HTTP 27.0.0 8000. I just typed crypto in the search box and House shows me every crypto class the app is currently using. I click on AES decrypt, click hook method, and it auto-generates the Frida script. I hit run. And now every time the app decrypts something, I see the plain text in my console. This used to take 20 minutes to script by hand. Medusa Automated Android Analysis. Last one, Medusa. This is the newest tool on the list and honestly one of the most powerful. Think of it as an automated Frida script library. It has 200+ pre-written modules targeting specific vulnerability categories. One tool to rule all the dynamic analysis. What it does, Medusa, is an extensible, modular Frida-based framework with over 200 modules covering cryptography analysis, network traffic interception, web view exploitation, clipboard monitoring, intent interception, key store dumping, and biometric bypass. You activate modules like plugins and get comprehensive runtime coverage without writing any code. Best OS? Kali Linux. Best native support? Ubuntu. Good Windows. Not recommended installation plus real commands. You can go ahead with this after that use these commands. Inside Medusa shell, 5 modules active. Every hash, every HTTP call, every preference read, every SSL operation all logged in real time. This is what a professional Android pen test looks like. And all of this is free, open source, on GitHub. Outro. So that's the full arsenal. MobSF for automated scanning, Frida and Objection for runtime hooking, JADX for decompilation, Apktool for patching, ADB for device control, Drozer for attack surface mapping, Burp with SSL bypass for traffic interception, House for GUI-based Frida, and Medusa for everything at once. The best OS? Kali Linux. Every single one of these tools either comes pre-installed or installs in one command. If you're serious about mobile security, spin up a Kali VM today. CTA. If you want the full install script that sets up all 10 tools at once on Kali, link in the description. Drop a comment with which tool surprised you the most. Like if this saved you hours of research. See you in the next one.